Okay, so today we're going to talk. Oh,
I don't need to wear this? Oh, I'm in my own house. Okay, today we're going to talk buffers. And so what I have is a pH pen, and I want you to pay very close attention to the pH on my screen. You can see it's just above 6, kind of, right now it's at 7. So I'm going to stop this and collect it again. You'll see what's happening. And what I have the pH pen is tap water. So I'm going to put some universal indicator. You can see it's green, which means neutral. And what I'm going to do is I'm going to put a drop of 0.10 molar hydrochloric acid, and I want you to see what happens to the pH. I'm going to put maybe 2 drops in. And you can see a dramatic drop in pH. Now look at the color of the indicator. It's red. So what that shows is that by adding an acid to the water, it changed the pH dramatically. Now I'm going to add some more tap water. And I'm going to put my pH pen. You're going to see it go back closer to 7. All right, now I'm going to put some universal indicator in this sample of water. It's going to be green again. But this time I'm going to add 0.1 molar sodium hydroxide, a strong base. And let's watch what happens to the pH. I'll put 2 drops in. And you can see that the pH dramatically shoots upward quite rapidly. And then if you look at the solution, it's purple in universal indicator. Now what I would like to do is I have a buffer, and the buffer I have is made from 0.10 molar formic acid and 0.10 molar sodium formate. So this is the weak acid, and this is the salt of the weak acid. I've already pre-mixed them, so I'm going to pour some into these wells. Now the pH to start with won't necessarily be 7. But the pH should stay the same. So we'll measure the pH of the buffer to begin with. So this buffer has a pH of just below 4, being that's the pH of a weak acid and its salt. So what we're going to do is we're going to add a couple of drops of the hydrochloric acid, and let's see if the pH changes dramatically like it did previously. So it's that same acid. I put in 2 drops, and you see a very slight change, maybe 1/10. Okay, let me put in some more. 2 more drops. You don't see that dramatic drop because we have the buffer. Okay. 6 drops. 7, 8, 9, 10, 11, 12, 13. Got so 13 drops, and we see a little dip, but not significant. 14, 15, 16, 17, 18, 19, 20. So 20 is an entire milliliter. Eventually, we would overwhelm our buffer, but you can see it's done a pretty good job of maintaining the pH without huge drops. And I put a milliliter, 20 drops of my acid. Okay, let's do the same thing again, but this time pour my buffer in here. Again, that's the buffer of a weak acid and its salt. Okay, so let's stop and we'll collect again. So this buffer has a pH of 3.84. We can have a buffer at just about any pH we want, which is what you'll be learning in this experiment. All right, so now I'm going to add sodium hydroxide. And remember, when I added the sodium hydroxide to water, the pH shot straight up. So let's see what it does. I put 3 drops in to my buffer. Wow, it didn't hardly budge. 4, 5, 6. So you can see this buffer is doing a great job of maintaining the pH. The pH now has gone up to 3.91, changing very little. So you can see quite dramatically that the change is not that significant. Now let me add some universal indicator. Remember, it was purple. And you can see that even though I've added a significant amount of hydroxide, filled the well, has not changed the pH much at all.